If you look at this picture, you just see an image of a dog. It's a blurry, poorly lit, completely ordinary photo. But for a long time, this exact type of boring, low-resolution photo was used to hide one of the most sophisticated espionage rings in modern history. Now, in June 2010, the FBI executed a coordinated raid across the United States. Now, they arrested 10 people living in ordinary suburbs, working ordinary jobs. Now, these weren't ordinary citizens, though. They were deep cover sleeper agents working for the Russian SVR. So the original pronunciation is a little heavy on the tongue for me, but here's the full initialism. These agents had been living in the US for years, receiving secret directives from Moscow. Now, the immediate question is how they managed to communicate for so long. We live in a time where we have massive electronic surveillance. We all agree on that. Now, if a computer in the US starts routing heavily encrypted traffic into foreign intelligence networks, you run a huge risk of lighting up cybersecurity tripwires. The encryption might hold, but the weird traffic pattern alone can invite a lot of unwanted attention. Old school methods are also risky, because if you broadcast a signal from a shortwave radio, modern signals intelligence can often hunt down the transmission source. To survive as a spy today, just encrypting your message isn't enough. If intelligence agencies know a message exists, you are already in trouble. You have to hide the existence of the message itself. And that is exactly what this network did. They didn't rely on the dark web or burner phones. They logged onto normal public internet forums and uploaded incredibly boring pictures of things like flowers and other images. And for years, this method kept their actual communications hidden in plain sight. To understand how they did this, we have to closely look at the underlying math of a digital image. But I'm not going to explain about compression algorithms and all these things. It's just a brief overview so that you can understand how they did this. Every digital image you see is a grid of pixels. Every single pixel is made up of data. Computers read colors using the RGB model, the red, green, and blue. The exact shade of red, green, and blue in every pixel is represented by an 8-bit binary number. Imagine a single pixel in our photo of this dog. The red value of that pixel is dictated by a string of 8 zeros and ones, something like this. Now, in computer science, the first digit on the far left is the most significant bit. If you change that first digit, the value of the number changes drastically. The color of the pixel would violently shift, maybe from a dark red to a glaring pink. Now, anyone looking at the photo would instantly know it had been tampered with. But look at the very last digit on the far right. That is the least significant bit. If you change the final 0 to a 1, the numerical value changes by a fraction of a percent. Now, the color of the pixel shifts by exactly 1 out of 255th of its original value. In a standard photograph, a difference that small is practically invisible. To us, a dark red pixel just looks like the exact same shade of dark red. If you want a more detailed info on this, you can look at the video pop-up at the top right, or you will find the link in the description. Back to the video. The Russian intelligence knew this least significant bit is the least important part of the visual data. You can manipulate it without destroying the picture. If you take a text document, convert it into binary code, and replace the 8-bit of every pixel in a photograph with your own data, you can embed an entire secret file directly into the image. This technique is called LSB steganography, and in the 2000s, it was a brilliant form of digital camouflage. When the spies uploaded these modified images to public websites, standard security filters usually ignored them. Now, the files were perfectly valid images, unless an analyst knew exactly what they were looking for and ran specialized tech analysis software to hunt for statistical anomalies, the picture just looked like a normal JPEG. The spies found the holy grail of steganography. They built a system so mundane that observers wouldn't even know there was a secret to uncover. But the story doesn't end with this interesting math. The FBI wasn't completely in the dark. Through traditional physical surveillance, they actually figured out who these spies were. The FBI launched a counterintelligence investigation called Operation Ghost Stories. They followed the agents, bugged their houses, and watched them sit at their computers to upload these boring photos to the internet. The authorities suspected the photos were the communication method, but knowing someone is a spy and proving what they are sending are two different things. In a court of law, you need proof. The FBI could download the photos, but the math behind LSB steganography, well, Sometimes it is incredibly stubborn. The Russians didn't just hide plain text in the pixels, they heavily encrypted the text before hiding it. Now, even with the files in hand, breaking the encryption inside the hidden pixels was a challenge. Without the actual encryption keys used to scramble the data, proving what the messages said was incredibly difficult. The US government had the spies, but building an airtight legal case out of encrypted image pixels was a massive challenge. If the math was solid, how were all 10 agents simultaneously arrested, convicted, and deported in the summer of 2010? The intelligence community didn't need to mathematically brute force the encryption. They bypassed it. They realized you don't need to crack a flawless digital system if you can just break the humans running it. Back in Moscow, the deputy director of the entire Russian illegals program was Alexander Potiev. Sorry if I butchered the name. Now, he was a commander overseeing the sleeper agents and protecting the network. He was also a mole working for the CIA. Brute forcing a cryptographic algorithm is a waste of time when you have access to the guy running the network. Alexander compromised the system from the inside. He provided the US with the intelligence they needed to finally break this stalemate. The US government has never publicly declassified the exact technical steps they took to go from Potiev's intel to fully decoded messages, but we know his betrayal was the fatal blow. Once the FBI had the inside track, the mathematical roadblock didn't matter, and the hidden text was exposed. Now, with the decoded messages in hand, the FBI had their proof of espionage. Days before the FBI raided the agents' homes in the US, Alexander quietly slipped out of Russia and defected to the United States. He abandoned his post, knowing the network he helped run was about to collapse. When the FBI arrested all 10 sleeper agents, it wasn't because an algorithm had outsmarted them. I'm always fascinated by digital forensics sometimes. You can build an incredible system, you can manipulate tiny or minute data of an image just to hide a state secret in plain sight, and you can also create a flawless logic to camouflage your entire operation. But your math is only as secure as the human being holding the password. That's it for today. Thanks for watching, and I will see you in the next one.